is a transfer case just like we're using. We're not using this exact one, but they're identical. Of course, what we end up doing is cutting this off about right across here. Those pieces you probably saw in the other part of the recording. And then we don't need any of this, or the chain drive, the gears, or the clutches, or anything, you know. And this does have a it's got a synchronizer gear in it, which we don't need at all. The only thing we're going to use is high range, low range, and neutral. So, the case off the old one that we cut apart, and you can see it's a new process 241C. The ratio is 272, so it should give us some pretty good reduction. We made this bar to seal off this end. It's a piece of 1 inch by 1.25 inch key stock. And it's got bolts, 1/4 inch 20 bolts, and both ends, plus there's 3 that hold the edge of the case up into here. Then we cut a plate. This is a 1/4 inch plate, and cut it out to fit the case. Drill the holes, and we'll use the original bolts that go back into it. After we've got this fit together and get our shaft length and size figured out, then we'll line this up and drill a hole for hopefully this one. It's already got a bearing and a seal in it. We'll just cut this off around here and then machine it down so the back part is flat. We'll take all these off and then drill holes, bolt it right to the 1/4 inch plate to hold the shaft. Okay, you can see here we cut this off. We're going to try and use this bearing support because it's already got a seal mount ready to mount in it. If this works for our output shaft, then we'll be in good shape. You can see I'm starting to machine these braces off. I've still got a ways to go. Then we'll dial it in on the inside to make sure that once we get out to this flange, it's true. I got these 2 shafts cut. This is shaft out of the transfer case. This is the output shaft off the transmission. So I cut it off here. We're gonna get rid of that and mount that like so. Of course, these are both cut too long. It's easier to machine it down than it is to add back to it. I tried to cut these off with a bandsaw. It didn't even scratch it. So I had to cut it off with a friction saw. And probably any machine work I do on this, I'm probably going to have to grind it. I doubt if I've got any tools tough enough to machine them, but we'll find out. After we got it welded together, this is the piece that we cut off that shaft, and this is the piece that we cut off this shaft. And I meant to show or record how we did this joint, and I got so excited about putting it together I forgot. But we drilled a 3/4 inch hole in this piece, and then we put a 3/4 inch tang on this piece, about 1/4 inch long. Because we machined a groove for the weld, another 1/4 inch, so that's why this is about 1/2 inch wide. But and then pressed it together. It's about a 2/1000 interference fit to put that together. Turns out this is not that hard. We were able to do all this machining with a carbide tool bit. The teeth are case hardened, but the shaft, after you get past the outside surface, is not too bad. We were able to drill it and machine it pretty easily. We dialed in our shaft. It's about 15 thousandths out of straight from the weld to here. So what we're going to try and do is heat this up a little bit right here where we welded it. Hopefully what it'll do is expand this shaft and it'll go opposite of what we want, but when it cools off it should come back toward where we want. At least in theory. Every one of these I've ever done is different, primarily material or how the weld was put in. We might have to try it twice. It may go too far. But if we can move this about, well, I don't know, 30 or 40 thousandths in the opposite direction, it should bring it back in pretty close. We'll see. Now we heated it up, and it moved this from the 0 mark right there clear down to 70 before I really got it hot enough to. We need to bring this up to cherry red, or it doesn't work right. So I heated it a little bit, and now you can see it's pulled it back about 6 thousandths. Still moving a little bit, but we only have to move like 7.5 thousandths, so it looks like it's going to be pretty dang close to what we want. It's cool enough, it doesn't burn your fingers. You can see where we heated it. A pretty good hot spot right there. It settled out about 6.5 thousandths. So we're gonna reassemble this back in the case and just see what it is once it's mounted in there. Now we found our center for a 1/4 inch plate. We mounted the plate onto the case and then mounted it to the mill table. Then we dialed it in on this surface so we knew we were centered. Then we just put a long drill in there and went down, made a mark on the plate, and theoretically that should be the center of where we need to bore the hole. We got our mark. This is our drill mark right there. So then we could mark it for our bearing plate. if you can see these scribe marks, that's where our bearing plate fits. And then out here, this will be the lineup guide for the adapter, which of course will be on the other side of the plate. This is the inside. Okay, we're at a point we're going to put this together now. I want to point out a few problems we ran across and how we addressed them. One of them was this shaft right here is what the shifting port slides up and down on as it changes, goes from high to neutral to low. Well, on the old transfer case, that shaft was located by the other half of the case, and it came right up through this hole right here. Well, we're not using this case, so we had to come up with something to locate it with our new cover. So what we did was just set that cover right on top of the new one, lined up all the bolt holes, and then we used a line up center punch, run it through there to mark our spot. And we drilled it out for a 3/4 inch pipe. Drilled it and tapped it, and we took this pipe plug just drilled a hole in that end, screwed it into the hole, lined up perfect. It's going to work really well. Another thing we ran across was the fill and drain plugs. Notice are also on this other half of the case, which we're not using. So we had to put some new ones in. So this is the bottom. So we just went over here on this flat spot right on the bottom, which is the lowest point of the whole case. Drilled and tapped, and we're using the original plugs that came out of it. These are 20 millimeter plugs. So anyway, that's the drain plug. We came around here and put the fill plug just about halfway up the case. So it's something you got to consider on the drain plug. There's lots of room down in behind there. I don't know if you can see that or not, if I get out of the light. Anyway, there's lots of room in there. There's no interference for any of the shifting cams or anything. So you can put it just about anywhere on this flat surface and it'd be fine. This one here is a different matter. If you go too low, you'd be drilling into your ring gear for your planetary drive. So you got to make sure you get it up high enough to miss that gear. Okay, you can see now that we've mounted the new cover plate. We've also mounted the bearing and seal housing. A couple of things I want to point out about this adapter and how we put it on. We made We made this lineup plate out of a piece of 3/8 inch plate. We just cut it out with a torch and then put it on the lathe. We machined the inside so that it would fit on here. This lip height is only about 10 thousandths less than the depth of this, so there's not a lot of clearance there, which is good. We just don't want it to tighten up on the top of this lip here. We want it to tighten up on this flange. And we located it where we wanted it. You got to be real careful that you mount. That's your motor mount, transmission mount part, and it's got to be located properly. We use this old one. This is it's a different adapter, but we located this so that we would know where the bottom of the transmission is, and then we lined this one up with this one so that it's setting properly once we mount it in the vehicle. Once we got that done, we went ahead and welded it on here and took the plate over to the drill press. We drilled these and tapped them for 10 millimeter 1.5 all the way through the 3/8 ring and the 1/4 inch faceplate, so that when we bolt it on, it goes through everything.